very pleased today to have Dr. Michael Charles here. And Michael's in my department, Biological and Environmental Engineering, where he's an assistant professor. And he graduated from Cornell in Chemical Environmental Molecular Engineering. And he told me how familiar this, he just told me how familiar this room is, because he was a student here many times listening to many lectures in the same room, although he's never been in front of everybody before, I think. So, so he graduated from Cornell, and then he went on to get his PhD in Chemical Environmental Molecular Engineering at Ohio State. And then as a postdoctoral researcher, Michael studied the history of land-grant universities and the relationships with indigenous dispossession in North America. His expertise involves computational sustainability frameworks that include dynamical ecological models and telling data-driven stories that advocate for underrepresented communities. And his research group is particularly interested in the vital role that landscapes play in sustainability challenges and how ecosystem services promote well-being to the human population. So Michael's also a Dene or Navajo scholar, and he's dedicated to forming mutually respectful research partnerships with indigenous communities. His vision is to combine computational methods with community-centered relationships and translate his research into action. Along with his research, he worked with the International Indigenous Peoples Forum on Climate Change to advocate for indigenous rights, leadership, and self-determination within the UN climate negotiations. So let's welcome Michael. Thank you for coming.
Yeah, thank you, Peter. All right. Well, I'm very grateful to be here. It's good to see you all. It does bring back so many fond memories. I think I took thermodynamics, heat and mass transfer, mass and energy balances all in this room. So it's very nostalgic, and I really appreciate being here. Today, we're going to talk about quite a few different things. So I'm going to try to give a little bit of introduction to just my mindset and what I think about is what interests me as a researcher. What do I think is the current state of engineering and where there's some opportunities? I'm going to introduce one project to kind of walk us all the way through, think about some other projects that we have coming that we're currently working on in the research group right now. And hopefully we'll learn a few things along the way. So today I'm going to give a talk that's called Empowering Vulnerable Communities, Facing the Consequences of Climate and Climate Action. So I want to kind of give an introduction into this traditional engineering mindset. And part of what I want to kind of think about is how has engineering even been developed? If we think about from the beginning of probably the mid-1800s, when we think about the Industrial Revolution and this huge boom of what engineering was and the development of a field that was trying to create practical solutions. But most of the work that we did in this case was really driven by how do we help humans, right? So everything has been kind of how do we control, how do we dominate nature and different ecosystems around us so that we can get the maximum benefit to humans. And that's what we're going to call our anthropocentric outlook, right? Dominated right now. I also think at this point we're struggling a little bit with what it means to be civilized and to be part of civilization. And part of this, by definition, was around domination and transformation of land. We're going to talk a little bit around indigenous dispossession later, but one thing that's really interesting to think about is how essentially there was a disconnect or a dissonance around what it meant to be somewhere, to live somewhere, right? And so a lot of what people thought gave them the right to kind of move in, right, was that someone else didn't do something to completely alter the landscape. And so that's fundamentally where there was a difference in how we define civilization. And so I think that's something that continues to come back into some of the work that we do. We also think about how we've included nature, right? When we think about any of your courses around maybe process systems engineering, thermodynamics, anywhere where we're taking something into our process, our chemical reaction, and we're throwing something out. In this case, nature has just been a source for those resources and then just a sink for our waste, right? It just kind of goes off into this infinite atmosphere, infinite sink. We know that right now we are experiencing the impacts of uncontrolled scale of activity, resource extraction, and we're observing this through different environmental degradation, impacts of climate change, global warming. We can actually kind of go through, if anyone's ever interested, you can go through just about every status of ecosystems. We had in 2005, probably our biggest report, which was the Millennium Ecosystem Assessment. But one thing that we see through the development, right, we have to kind of think about what does it mean for us to be sustainable in society, to promote human well-being. And a lot of this we attribute to the technological advances, right? This generated money. We circulated resources through an economy. We've continued to improve that. You know, we're seeing increases to the longevity of human life, right? Lots of good things have come out of our technological advancements. More recently, we're starting to see some of that dollars shift back towards environmental conservation. We're starting to think about, you know, what is sustainability? What do we need to protect? We've seen some pretty irreversible changes to different ecosystems. Thinking about ozone layer in the 70s and 80s. Thinking about other environmental conservations, a lot of water quality issues stem this, and then air quality, right? And one thing that we've started to put dollars back towards is kind of putting it back into our ecosystems, thinking about how can we actually promote better capacity. One thing that we haven't seen though change as we see these increases of GDP is our relationship to nature. And so this paper actually came out, it was focusing around ecological literacy. So just the ability for anyone in a given place to just go around and name some of the plants around them, name maybe what they're used for, just have an idea of what plant life is around them. This study compared this against countries and their GDP, and they basically found that there was a complete inverse relationship, right? So the higher a GDP was of a country, the less likely any of its citizens were to be able to name the different plants and animals around them. So this is kind of the frame of the traditional engineering mindset that I often try to kind of talk about, and we'll put some contrast to. So I'm going to give a story that you might have heard before, and this is kind of the 6 blindfolded scientists and an elephant. And this is kind of a story where there's 6 different people, right? They're each observing a different part of this elephant. And because of that, they're blindfolded. They have a very different guess in terms of what they're interacting with, right? So someone touching the trunk is assuming it's a spear. Someone playing with the ear is like, well, look at this giant fan. Someone up on a ladder is just stuck against a wall. Someone touching the trunk is like, what is we, exploring with a snake? We have a tree as the leg and a rope as the tail. And what I think is interesting about this, right, is we think about perspective and what this means for our actual conclusions and what this means in terms of our science as well. But I think it's important that we also give credit to how our science has been developed. And so one thing I want to point out is we're going to talk about this contrast between reductionist thinking and holistic thinking. And just in case anyone wants to put up their hand and answer, how has reductionist thinking been a driver of our modern sciences? Any thoughts?
It allows for specialization.
It allows for specialization, absolutely. Any other thoughts? It allows us to focus, right? To make things a little bit more simplified, manageable. We can look at these complex phenomena and put a box around it to help us understand something, right? So the more and more we zoom in, that's how we see the development of new medicines, development of new chemicals, all of these things that we have kind of, if you think about it, have helped promote different parts of human well-being. And none of that would really be possible if we try to just tackle every problem or grand challenge of the world at once. So I want to give us a little bit of thought around the difference between this type of science. So my argument when we think about how our science was developed, it could be kind of simplified into this idea that we were developing science for an empty world, a world where anthropogenic activity was pretty small compared to the rest of what was happening in terms of the Earth and the Earth system. And now we're kind of coming to these realizations, right, that the atmosphere, the heat we were losing, the CO2 emissions is not just this infinite sink, right? That's this development that we're all studying called climate change. We're thinking about how do we respond. And I think one thing that we think about is now we're at a point where this is just not our situation anymore. We've done enough activity that our footprint as humankind is now the main dominant footprint onto our Earth. So how do we respond? How do we think about what our science looks like in the context of this full world? This is kind of where I get really interested in the approach we take to our science. We think about holistic research, systems level thinking. And I also try to argue that it's really important for us to balance both. So is there a way that we can balance both the reductionist research that enables us to comprehend this complex phenomena with the smaller, more manageable parts, with this holistic research that analyzes interconnected systems, thinks about emergent behavior, the role of what happens when your neighbor is in the room, and maybe some of the potential consequences that comes out of it. And so this is where I think there is actually a huge need for science to kind of have this relationship between reductionist approaches coming up with these new and improved technologies, working with holistic researchers to try to look at the impacts of sustainability, thinking about the consequences, and then also thinking about those opportunities for improvement. One thing that we can emphasize and learn from Einstein is just we cannot solve our problems with the same thinking we used when we created them. So I want to focus on this idea of what makes sustainability a challenge and how can we help ourselves see the bigger picture. So the first thing I want to kind of coin sustainability is as what's called a wicked problem. Wicked problems have been studied for quite a bit. Another two good examples of things that might be considered a wicked problem are the pursuit of happiness and maybe raising a child, right? And what makes these different problems challenging is there involves lots of complex systems, lots of choices to be made. There's not one right answer, right? There's going to be some trade-offs. You might do something that's good that then just has a negative impact somewhere else. There's ill-defined end goals, sustainable. We're gonna have an inability to know if we're succeeding. We only will know that in hindsight. So if we think about sustainability, what makes it so tough, all I can tell you is what's been unsustainable, right? We don't have an example of what is sustainable. It's also interesting that there's never going to be a right or wrong answer. We're just gonna be able to do better or worse. And that's one thing that we need to think about as we start trying to formulate the metrics that we have. Is relative sustainability good enough? Are there ways that we can move more towards absolute metrics? And that's where I'm going to kind of pose these different requirements for sustainable decision-making. It's important to note that these are necessary, but not necessarily sufficient. So just because all of these things have been satisfied doesn't necessarily mean that we are sustainable, but it's hopefully a good indication we're doing something right. So these requirements are going to consider shifts across multiple spatial and temporal scales. So we need to be thinking about, do the decisions that we make just push the problem somewhere else? A good example of this could come with thinking about just maybe even carbon accounting, right? And so one thing we can think about is if we're just kind of avoiding our responsibility for one given institution or process, business or industry, are we just kind of making a decision that's going to push it down our supply chain, right? There's lots of times when that's very much the case in the reality, where we're able to claim something that we did good because now we're going to impact the supply chain somewhere else. Also thinking about temporal scales, not just necessarily from the analysis, but possibly the design. Different systems act on different time scales. One of the examples of this is thinking about the rate at which maybe the rate at which a new tree could help with air pollution in your region, right? So if you had really bad air quality and you thought, let's go plant a bunch of trees, one thing that's going to be helpful is that it's an investment in your future, but maybe for the next 20 years, it's not actually helping your air quality. It might not be having that impact on human health. So matching the temporal scale is very important. We also have to think about cross-disciplinary effects, thinking about trade-offs between sustainability of different environmental impacts versus maybe social acceptance, social embracing of different behaviors, economic impacts. All of these things need to be thought through if we're really going to see these things translate into change. Evaluating interactions across multiple flows, very important one when we think about how we typically are thinking about sustainability and how we define it. A lot of times it's been a one-to-one equal statement with let's just reduce our carbon emissions, right? But in many ways, when we think about the development of new renewable technologies, we're going to maybe help with our CO2 flows, but we might be shifting a lot of those impacts, whether it's to mining, to water sources, whether it's something across the supply chain that also we're not considering. So thinking about interactions across multiple flows. And finally, one thing that I think helps us move from a relative metric into an absolute metric is thinking about how we account for the demand and supply of ecosystem services. So rather than constantly saying we're going to do relatively better than the way we're doing, how can we compare what our activity is actually doing to maybe the footprint of our biosphere to actually handle that? Again, depending on what your service you're looking at, then spatial scale is going to become really important, whether we're thinking about air pollution, which is going to be something that's much more localized, or CO2, which is going to have a much more global service shed. So all that to just kind of give a background into what is usually going on in my head when we're thinking about new activities for research, and kind of also similar to the classes I teach. But I'm going to talk a little bit about some of the background and what we're doing in our research group right now. And so we're focusing really around systems engineering, that holistic thinking, and sustainability assessment. So we're thinking a lot within nature responsive design. So trying to figure out the boundaries that we've created in our traditional engineering mindset, which has been throw a box around our technological system, come all the way, think about all the ways that we're going to design our processes, our unit operations, piece them together, and optimize. We're interested in how do we actually take that border and make it a little bit wider. How do we start thinking about ecological systems, social systems? Can we make technological systems to design more responsive to the capacity of nature, whether it's just even the existence of the system to begin with, or the way we're operating it, whether it's day and night, seasonal, thinking about all those temporal and spatial dynamics as well. We also have a core focus around the development of novel sustainability assessments and design frameworks. So thinking critically around how we're actually assessing, quantifying sustainability, and what are some of the current limitations of our design frameworks, and what do we need to do to expand them. An example of this is we're working around social life cycle assessment frameworks to think about socioeconomic impacts of processes and connecting it with some sort of standardized census data. Because at this point, one of the biggest critiques is it's just not very well standardized. We also can think about how do we design technological systems based on trying to design them the way maybe a food chain operates or other things that we're observing in nature. So we do a lot of work around networks as well. And then finally, I'd say our last kind of third core, and every time I kind of present, I feel like these change a little bit, but I see the third pillar of our group right now being utilizing data sets to empower decision-making at community scale. A bit on the nature responsive design when we kind of dive into some projects. But here the focus is really around how do we generate useful data, localized data sets that help people make decisions, whether it's around mining, we're doing some work around research governance. How do we help connect dispossession of indigenous peoples to impacts on their food sovereignty today? How do we help those communities understand what that means? And we've kind of come up with this other framework that helps guide, I would say, our work in terms of our relationships with the communities. I think we really focus around our research being an opportunity to work on training, capacity building. So that's the students here on campus, that's any of the community members we're working with. We try to figure out what are some of the ways that we can create products. So information and data, maps, software and tools. Can we give them that information back as a tool that they can use? So thinking about the community education part. And then trying to get some feedback, thinking about what is useful to them. You know, they can decide that, not necessarily us. What is helping them make decisions? What is just completely within our own heads of being useful? And then how do we come back to think about community needs assessments, project redevelopment, data collection plans, things like that. And where I see most of our work moving towards in terms of working with our communities has been really focusing on safety and empowerment. The end goal hasn't been for us to tell them how to do something, whether something's good or bad, but to help them make their own decisions. And then the other end of it being to make sure we're promoting some sort of safety, whether it's through public health, or even when we're vulnerability to further dispossession, which we'll kind of talk about one of those projects. So before I kind of go further, I want to just kind of make this clear that all models are wrong and some are useful. And so because we focus a big part of our lab on modeling, I think this is one thing that keeps us very humble, but also thinks about where we need to put more effort. You know, how much effort is being out there where we're just trying to continually make our models more and more accurate versus how much effort are we actually trying to listen to the community, make it more and more useful. And so obviously we're trying to make it as accurate as possible, but I think there's a lot of labs doing that. And so one of the things we really try to focus on is having that community feedback to focus on the usefulness. So we're going to dive into a few projects that focus on climate impacts, specifically on vulnerable communities. We're just going to start with one of these projects and then kind of give some more summary overviews of others. So this project is going to focus really around balancing the demands for transition. So I'm going to put forward that we do need a rapid and just energy transition if we have any chance of meeting Paris targets. So this is going into the Paris Agreement, thinking more on the international agreements to figure out what does it look like to be more sustainable and have global cooperation. We know at the current state, we set this goal of let's try to be less than 2 degrees Celsius and ambitious if we can keep it within 1.5 degrees. We know at 2023, we had our warmest recorded year since we kept global records. So since 1850. And on that year, 2023, we were already at 1.35 degrees Celsius. Also going to put out there that Indigenous communities are at the front line of climate vulnerability, and this is due to their integration of landscapes in their livelihoods and their economies, their inherent closeness to natural ecosystems and the reliance of the economies to begin with, but also thinking about the communities that are out there farming their own food, herding their own sheep, and not as reliant on these giant supply chains to provide for that. That to make adjustments when one local area sees these huge shifts in climate. Work with the International Indigenous Peoples Forum on climate change. So I can go on and on about different stories for how these Indigenous communities are impacted in different regions of the world. And I also myself come from the Navajo Nation, so Northeast Arizona, thinking from the Southwest and desert climates, which you'll see a couple project examples there as well. But what I think makes this balance so important to think about is political marginalization. When you think about the political power of Indigenous communities within their federal governments or whatever that looks like in terms of the relationships between the communities and their hosting governments, there's a clear power imbalance. There's a lack of representation to make decisions, and there's just further risks to include loss of land and resources when we think about including ecosystem services or carbon market trading schemes that are going to be reliant on the amount of land that's sequestering carbon, right? This makes them vulnerable communities to this. We think about the resources subsurface. We're going to talk mostly around minerals and mineral rights in this project. And we think about the potential for human rights violations. It could be opportunities that help them integrate further into these economies, but it's also a very clear risk of human rights violations or Indigenous rights violations. And we can also see if there's these power imbalances as these decisions are making discrimination and unemployment, essentially shifting these people out of where their current land is and not allowing them to have any of the benefits that we might see in some of these energy transitions. So I'm going to pitch a project to you all. We're going to kind of dive into it a little bit. And this is around thinking about how can we connect our knowledge of and projections of future energy scenarios with some form of sustainability assessment. We're going to do a little introduction to life cycle assessment or life cycle analysis, thinking about all of the needs that we're going to have in terms of materials, different impact assessments that we have with these future energy scenarios, look at current known maps of mineral deposits and try to connect where these might land on Indigenous stewarded lands in the United States, and just think about what can this tell us in terms of risk or opportunity for these communities when we think about the energy transition. So again, objectives stated here is connect the projected increase in subsurface minerals due to energy transitions with specific communities who reside on or near these resource supplies. So we're going to first just kind of talk about some of these future energy scenarios. The office for us that conducts a lot of this work is the US Energy and Information Administration, and they work on these market-driven energy scenarios for the US. So one thing to note is that these are very much driven by whether or not these technologies are going to be profitable, whether or not they're going to fit within the current market schemes and kind of rules. We also know that we have some projections, so thinking about different scenarios, what might happen, if we see advances in zero carbon technology, we're going to see different options for having that be cheap cheaper. Thinking about for those minerals and subsurface resources. We also can see that these scenarios are going to project somewhere between 2 and 3.5 times the increase for renewables. So in this case, in the graph I'm showing you, the solid lines are going to be just the growth of what we're calling renewable energy touches each of these. Just to note that there are these different scenarios that we work with, whether or not there's an Inflation Reduction Act, whether there's no IRA, low IRA, high IRA. We have the same for zero cost technology and similar for low economic growth and high economic growth scenarios. We're going to just kind of focus on the reference case moving forward, though, so we don't have lots of different layers of data that will confuse us. One thing I want to kind of first notice is thinking about what we know about sourcing this changing energy landscape. One thing that kind of first kind of struck me is if we look at this and we're seeing what's our projected use, what's one thing we notice about all of the given sources right now? Do any of them completely go away based on our market trends? No. What do we know about our total energy as it's anticipated? It's increasing, right? So one thing that I always find interesting as we talk about energy transition is in many cases, it's actually more of an energy addition where we're actually just trying to use renewable energies to continue to increase and make more and more energy to be consumed. So in some cases, we're just going to make this assumption, but we can also be thinking about what does that actually mean in terms of these assumptions. You know, is there possibilities for us to consume less? Just as kind of more of a hypothetical and philosophical question for you to think through. But I think it's interesting just to think about how we're expecting to see these shifts. Again, we're going to see most of the focus being on solar photovoltaic, wind having a decent increase. Nothing else really is going to have these huge shifts that we might expect, according to our current projections. I will also note that this was data taken last year, if that helps think about any of the projections. This might be our better case if we're thinking renewable energy. So this is kind of where we started connecting this. If we have all of this energy and we know the different transitions were or just the projections of where we might source our energy from in 2050. And so what we do in our lab, we do a lot of work around life cycle analysis or life cycle assessment, which is essentially different processes where we start from the process flow diagram. Where does this energy come from? We think about what's the functional unit or product that we're assessing. And we just try to work backwards to think of what is everything that is required for us to make this. These data sets have been developed now on such a large scale. We can do it for an economic sector. We can do it for, we have federal data sets for life cycle analysis for these different energy sources. And you could also build it yourself if you look at different papers and can build your own process model. We focused on focusing just on the minerals. We'll show a few of the impact assessments as well. We were interested in what we've defined as primary, secondary, other impactful minerals. And then we also have data for the rare earths, but we aren't going to show them today. But what you see is basically an increase in all of our minerals. If we want to, especially when we're thinking about the wind and photovoltaics as being the biggest change in projection of energy, this is what it's going to cost to build that. So we're going to need all sorts of these minerals. One thing that's interesting is the difference between coal. That's why I put both of these as, it kind of looks good if we're going to switch away from not powering and using as much coal, that's where we see this trend. We're going to use a lot less hard coal because we saw a little bit of decrease. Why do we still use a lot of brown coal or soft coal? Does anyone know where that might play? No, not quite. Like charcoal, is that what you're thinking? Like more of a biosource? Not quite. It's actually being used as a raw material to make steel. And so if we think about the frameworks in which we're going to have to put photovoltaics up, we're going to have most of that being the actual photovoltaic material and steel. So a lot of our coal mining actually continues to increase. It just means our most high energy hard coals that we're going to burn for combustion might decrease. Similarly, we see a drop of iron and manganese, which is similar just because of the kind of time that we expect it to change from different energy sources. What's also interesting is not just looking at the raw materials going in, but I mentioned that we don't want to just shift our impacts, right? So if our only goal is to reduce CO2, that's where we see our global warming potential in the top left. Every single one of these scenarios we're technically doing better in, but we're also shifting all of our impacts onto water, onto land use, water toxicity to ecosystems. For ozone, we're actually reducing our impacts for ozone depletion potential, and most of these are going to actually have a positive impact on human health. The question is, how do we make decisions between these? One thing I find really interesting is actually the lowest impact for water, land, ecosystem health, and human health actually is the only one that was based on a political policy change. And that's our high uptake of the Inflation Reduction Act. Does anyone have any thoughts around why that might have the lowest impact? It has to do with the assumptions, right? All of these scenarios were driven by projecting markets. The Inflation Reduction Act, what that allowed us to do is put some subsidies on certain technologies, which means that we actually have more of a balance of renewable energy sources. It doesn't mean we're just only going to maximize and take the only one that we project to be profitable, which is the solar photovoltaics, which is why we see such a huge shift. That one allows us to have some subsidies so that the market can actually help balance out and use multiple technologies. So because of it's not driving one technology and assuming that that's going to be a solution, that's actually where we see a much better balance in terms of these impact assessments. So one thing it could talk about is maybe the potential value of policy, future policies, and maybe thinking about regulations or interventions to existing market rules too. And then we think about how do we work on then conducting the spatial assessment. So we basically learned that all of the materials that we're tracking in terms of these minerals are going to increase. We're going to be mining more and more. We'll talk about this at the end, but there's not a huge reliance of our own domestic mining. So thinking about how that might play a role, but let's pretend we're going to source things domestically. We were able to work with the USGS's mineral resource database, find all of these data points around known deposits of these different minerals and metals. They are, because these are all subsurface data points. That's what the different colors are. They're not actually the different materials, but how confident they are in the existence of that metal or mineral. It also could be categorized by currently mining, projected or prospected mine, or just known deposits. So there's also these different categorizations of how confident we are in terms of what's being mined and what might be the next focus in terms of the mining industry. And so one thing we also were able to do is thinking around how we do these using kind of GIS software, adding these buffer zones. So thinking about how far away would a mining impact a certain community. This says 10 to 100 kilometers. We actually mostly focused on the 10 kilometers, so not actually that far, right? So we're thinking about if you took a border of anything just within 5 to 6 miles, that if there was a mining operation on the other side, it might impact the groundwater on the other side. Some of these estimates go up to 100 kilometers. We worked with actually a news reporter who was interested in this map that I'll show you later, but was really interested in a very specific buffer zone of 35 kilometers. Most of the literature tells us it's mostly arbitrary. We went with the most conservative estimate because we think it still tells our point the best. So what were we able to do? We were able to come up together and create this map. So just in identifying mineral deposits on tribal lands across the US, trying to figure out where are the biggest hotspots that we're going to see shifts in the mining industries regarding the energy transition. What we found is the Southwest, which is already one of the bigger mining operations, the Northwest, even Idaho as well, Alaska, which is actually a huge mining industry. And then some of the other places, they still have these known deposits, but maybe won't be as as at risk or uncertain in terms of their future. So this map was a good thing to think about of how could we kind of get the big picture. But what we had to think about is this actually useful to make a decision? If I was a tribal government in any of these one places, does this map help me make a decision? And we said probably not. It's good to have an idea of what we have at the national scale, but when we look into the data, we're actually able to come up with keeping this data set separate, making it more localized. So what we came up with were what I've been calling these kind of nutritional facts of all of the known mining mineral mineral deposits within each border from the tribal political boundary. We also were able to look at the critical renewable materials. We know that they're all about to increase, and look at the percentage that are just that are only on tribal lands, at least within the U.S. context. What we found is kind of, I think what to me is the main output is that the actual reservation land accounts for just 2.3% of the US, but it's not, are accounting for 11% of all of the mineral deposits, depending on what we're looking at. So copper at 11.6%, chromium at 13.9%, rare earth elements, right? We're seeing that most of these, in terms of if we're looking at the proportion of geographical options, there's going to be a huge focus on tribal lands for these different mineral needs. We also are just kind of able to kind of help rank these and show, you know, this might be a vulnerable list. If we were to look at who we should communicate this story to first, this gives us a place to work with. So on the far left is just rank. We're only looking for specific materials that are critical to the energy transition. But part of this helps us start to localize these data sets from having this large map, Excel sheets that have just tons and tons of rows and columns, right? This helps us try to figure out what might be the data set that each one of these communities would want. Who should we be reaching out to first, and how can we, again, make this more useful? So what could this mean for tribal nations in the US? We know that basically we're going to have this critical response of this energy transition, trying to figure out how do we reduce climate impacts. But the other question is, what are we thinking about in terms of all these other, put all this investment into energy additions or transitions? What might this mean? My conclusion from this really has been that the situation is really ripe for power imbalances. So it could be human and indigenous rights violations, but thinking about this need and want to become more sustainable, these global targets and cooperations to want to increase our mining of these different materials, and thinking about what might be stopping them. And in some cases, we can see, particularly if we think about non-US cases where there might be even more threatened human rights violations and things like that, we need to realize that even if it's the US funding and shifting these energy transitions, where might we be getting these minerals from? Where might we be contributing to these potential risks, which could also be opportunities? I never want to kind of say that this is not something that's worth doing, but thinking about what needs to be in place to make sure that we're not breaking into human rights violations. So thinking it also might be worth analyzing how many protected forests and natural parks also lie on these mineral deposits, and explore kind of the trade-offs between possibly mining and carbon sequestration. Are we really helping ourselves get to that end goal if we're going to go deforest a bunch of areas just to do the mining so that we can reduce our carbon emissions, right? So thinking about how can we get a more holistic perspective on some of these decisions. We're still doing a lot more work with how to use this data with communities. We'll show kind of some of our ideas for moving more towards developing softwares and community-driven tools. And this is actually kind of an interesting thought if you're looking at US mineral import reliance. This is the amount of minerals where we have 100% reliance on. So like 15 of the minerals that we're using in our industries every day, we don't domestically produce at all. 51 of them, we rely on 50% or more. So this could be a huge part of the story when we think about future trade rights and what those policies might look like when we consider international trade. So I'm going to shift gears a little bit. We're going to introduce another story and quickly kind of do some overview on some projects as we wrap up. But this was a great quote that I think helped actually inspire one of our next projects that we'll talk about, which is, there are many ways to be poor, but in today's world, not having the right kind of information represents a certain kind of poverty. As long as outsiders decide what is important and are in the position to ask all the questions, we'll never be able to solve our own problems. So this came from Mark Gordon, who was the chief negotiator of the Northern Quebec Inuit Association. This is also actually a photo from Nunavik, which is the northern part of Canada. That's one of my graduate students was there this fall and took this photo. And we're going to kind of talk a little bit around another idea for how to use the skill sets that we have in the lab as computationalists, as modelers, and trying to think about what other ways might we develop some value to community partners. So this is one where we're focusing around what we're kind of coining as a participatory AI approach, which is thinking about how can we use artificial intelligence or some form of machine learning to actually help communities synthesize information that already exists. And so this is a bigger collaboration where we're working with a few different universities, but really trying to focus on an end goal, which is creating Nunavik's own research database. So it's going to be an interactive and categorized map of existing research on Nunavik lands. Part of this is how there's been so much research that has been done on these lands, particularly around climate. If you see how far north they are in the red area, they're constantly getting researchers coming in, taking data, writing their papers, and then leaving. And none of this data has really come back to the community. And what was actually a shocking thing is they had found more papers than there were people in this area that had been published around this region. And again, it's not helping the local community at all. And one thing that they're really interested in right now as thinking about their ability to empower themselves as a community and act as a sovereign nation is coming up with their own rules for who can come into the land and who can conduct this research. So part of it is conducting this atlas so we can, one, help them try to synthesize what's already there so they can make better decisions around who can come in, who cannot come in to their community. And then also trying to figure out how can we make all of the research that's there more useful to the everyday person. And so we're working on this natural language processing model that categorizes literature according to the community identified practical topics. So where does the community come in? That's where we focus on the community consultation workshops, trying to figure out what might you be interested in if you knew there was, we're thinking around 20,000 to 30,000 literature pieces. What might be useful and interesting to you? How can we filter out so you can find the 1 to 5 that might be more relevant to your every single day? Thinking again about how reliant they are on information around climate, around species, thinking about fisheries, tracking. And so one of the things that came out of this, that we've already had one of the rounds of community workshops, was we don't really care if it's considered natural resources, environmental engineering, right? The department names meant nothing to them when they were sorting through this. They wanted to know by species, which of these could help us? How do we know can we look at just all fisheries, and then could we have another filter that helps us look for a given fish? And so we've been working on these different clustering algorithms that starts to try to give these themes that help us break these down and then look for different things. So this was an untrained model where we just looked at make 20 clusters of all the known literature things that we have and just see how close we are. So this untrained model we took to the community, said, here's what we are able to do right now. Here's how you can help us think about what would be useful clusters. Then we can start retraining it towards the categorizations that are interested in. So that's one of the projects we have around really focusing on empowering research governance. We also have a lot of different projects that are focused on Indigenous food sovereignty right now. So thinking about, can we determine high resolution impacts of climate change on future food production? Could we simulate or think about potential technological interventions? And can we determine what might be these economic impacts? So just going to kind of quickly give you some overviews around 3 different projects, and then we'll kind of wrap up and have some time for questions. But on the far left is an example of a project we have right now that's taking thermodynamic models of a vapor compression cycle, trying to figure out how feasible could it be to basically send a refrigerator out into the desert and try to pull just humidity from the air to kind of help with water stressed regions. Now, the main thing there that is important to think about is that's a very inefficient process, right? We're trying to pull water from where it's the most dry, and we're trying to figure out how to take some form of energy and turn it into water. And so what we're looking at there is how can we pair a photovoltaic system with these basically atmospheric water harvesters, but another term is just a giant refrigerator in the desert. Is there ever a good combination of when there's the solar availability to lack of water? Could we run it in, even if we just have small periods of time where it might be slightly efficient or not as cost intensive, and could it really help with water stressed areas in terms of agriculture? And then particularly think about how it might respond to climate change. We also have work that we're doing around doing these high level assessments of sweet corn yield. So thinking about crop specific impacts. This is for Navajo Nation, but we're interested in what we have currently is the state of global climate analysis models. So thinking about kind of global models that we're simulating climate change. And some of those, when we have integrative assessments, they're including some of the macroeconomic impacts. And so we might understand maybe what are some of the potential shifts in economies for a given country or a given region globally. But no one has really tried to do this at a high enough scale that might help smaller communities. So thinking about tribal governments as a small scale governing entity that doesn't get the same information that we might have at these larger macro scales. So that's where we're trying to fit in. We're starting with this work that's focusing around just specific species, doing the high resolution or downscaled assessments in terms of impacts on agriculture. And our goal is to then put it back into the economies, working with their tribal governance officials to figure out how might this help us change policies, or how might this help them plan and prepare for the future. The final project we'll kind of talk about is connecting dispossession of Indigenous peoples in North America with land grant institution endowments, and what has that done to food sovereignty. So here's an impact around lots of different tribes. What we see is the change in food productivity, change of food insecurity. So there's a general trend where we have had a big increase in impact on food insecurity. But what we often forget is kind of this history of our land grant institutions, including Cornell, that has had all of their parcels. So in the red is all of the land that was sold and founded to be the endowments of these universities, 52 different universities, and all the impacts it has and connects now to current present day tribal communities. So some of the novelty we had on this was trying to actually connect it to the present day impacts of tribe, and then added these layers of food productivity, food insecurity. We also have the change of temperature profiles over across the year. So thinking about how their farming might have had to change and adapt due to a change of temperature and precipitation. And so this is actually built on, if you're familiar with the landgrabu.org, it was this big story that came out in 2020. I've been working with some of the initial authors from that to add kind of these new layers of data to it. So this is just kind of a glimpse of all of the ways that I've kind of shifted from my start as in chemical engineering to thinking about how do we still use computational tools, thinking about even some of the engineering fundamentals. If you look at the far left, we have that project around atmospheric water harvesting is essentially applied thermodynamics. And how do we start shifting this into different packaged products and projects and collaborations with different communities that could give a little bit more usefulness, is what I was searching for, I would say, in terms of the research we were doing. We're also really interested in developing non-academic products. So how do we get this to not just sit in a journal article? This is an example of one of the tools that we're working, which is just a short software right now that's going to be more built like an app. This is for the dispossession from land grant institutions. And so within a tool like this, we know there's so many different ways that we could sort out that data and try to find the impact and try to help specific local communities figure out what to take away from this. So you can see that something like this might be also applied to our mineral work, but it's mainly trying to help figure out how can we sort through this data, get like lots of different combinations of the statistical impacts. So right here we have Cornell, the impact across all the tribes. We can find a table of every present day tribe that has comes from the parcel that was given to Cornell in the 1850s, 1860s. And then these different impacts that would happen that impact their growing system for their growing seasons for food production, and try to pull that information to a community level, right? Something specific to them. So we're just continuing to evaluate our work for usefulness. So I'll go ahead and wrap up. Really focus being around reductionist research alone can lead to these unintended consequences, right? And amplification of vulnerability to communities, if not balanced with holistic systems approaches. And at the same time, the holistic approaches that we try to do in our group is very limited still in the ways that we can develop new technology and discoveries, because we're often having to neglect lots of details and trying not to include too much so we can still make the right assessments, right? And so we're limited in the amount of data we can use to actually make these decisions, but we're still trying to build a bigger perspective and continue to add on to that complexity. But we need both perspectives. That's something I really want to take away. It's what makes me excited about kind of being here and taking this lab, bringing this lab to Cornell, is all of the partnerships we get to do with labs to see, here's their vision for the future, the technology they're designing, and we get to be the, can we help you see if, like, how that might, which of these consequences might happen? What are the opportunities? And so in some cases, it's been really fun because we get to think about, here's your design at lab scale, here's how it could scale up and be the future, but here's your giant limitation in terms of the supply chain, right? You might, thinking about, we're working with some biology labs where they require a ton of glucose, and some of their cases have been, well, if we scale this up to this giant global technology, everyone could use this, we might sequester carbon. Like, well, you have a clear limiting factor here in the glucose supply chain. What might be some other options? And that gives us other options to then think about, not just economically, but from a sustainability perspective. So constantly looking for how we collaborate between those two perspectives. Also, there is this need for urgent and scalable climate action, but we also must make sure that we do not just shift our consequences, whether it's across time, space, resource, discipline, pushing it onto another community, right? So we need to be very careful around how we make these decisions and how we can make these decisions quickly. Because I want to balance that. Last conclusion has been some of the inspiration for the work that we're doing in the lab, which is really from the communities we work with, right? They're bringing me their needs. They're telling me what's useful, what's not. And it gives me a great chance to evaluate everything that comes through in terms of our projects, our interests, how we might use the different tools and skills we're developing. And so in a lot of ways, it's been the innovation behind some of our projects, but it also has helped us practice, right, our patience, our humility, and really focusing on investing that time to build the trust with our collaborators. So with that, I just want to say thank you. In my language, it's a yeah, and I'm here for any questions. And thank you to all the students in my lab who did the work. Sure. Yeah. Any questions? I can call them.
I have a microphone, so.
Okay. I saw your hand first, so we'll start there.
I was just wondering if 11% of minerals was that 11% of like local mineral? Okay, so not just in the United States.
No, so just in the United States. So yeah.
So if it's just 11% United States, all 100% of these minerals, or would it be possible with that 1% use other?
Perfect. Yeah, so the question for the people on Zoom was around the 11% metric for the deposits on tribal lands, if that's just within the US or globally. That's just the minerals within the US. And the follow-up question was, does that mean we can just avoid these lands and not just not use that 11% and still do some of the domestic expansion? Yes, I would say that definitely means it could be left alone. It could be left as an opportunity for tribes to make that acknowledgement and say, we want to invest in this and build these industries on our land, right? Those are all opportunities that they could choose to do. What we don't have in terms of this data that is just kind of a lack of our ability to account for this right now is how much of each of those minerals do we actually have, right? So a lot of times they're able to find it. Some really well-known studied places like or an active mine site might have an estimation of how much capacity they have. So if we want to think about a supply versus demand, right, we have the supply data from the LCA of the energy projections. We don't have any very certain demand data. I'm still trying to pick the brains of some of the people over in Earth and Atmospheric Sciences to see if they can help me piece together any somewhat estimates or better estimates because we don't really have anything at this point. So the question is, yes, they could still focus on the other 89%. Will they? Maybe, maybe not. I think in a lot of cases, this still ends up being the tribal lands are some of the most undeveloped in the US. So the question is, are they going to dive into some place that's been urbanized and displace more people, or consider these rural communities the places that they're willing to do this? So we actually, one of my students, at one point, we had a layer that was also included the urbanized lands. And once you include that, that number goes from like, if you include the tribal lands, I think it was the national parks and forests and like heavily urbanized cities, I think it ended up being like accounted for 89%. Again, that's kind of a made up number because I would have to go back and look through the data, but it's a high number. So when it comes to like where they might make decisions, I would argue that there's still a good amount of vulnerability, but there could be these other aspects to consider where we expand for mining first. Let's start here. Yeah.
In your experience, how do you engage how do you engage with community stakeholders when building these projects? Is it like an active relationship, or is it more reliant?
Yeah, so the question was, how do we maintain our relationships with these communities? Is it an active process, or are we kind of relying on some of this data? Both. One thing that I find really important is thinking about the time that we're asking with these communities. So a lot of these communities relationships, we do have an active relationship. We use a lot of the data to try to figure out how far can we get to show them something that we can do so that we can actually help them understand better what we're interested in, what we might be developing, get our feedback, and then try to figure out, is this helpful? Do we need to pivot? So I would say there's a lot of both happening. We do rely on a lot of open data sets as well, thinking about how well can we characterize this? Do they have other data sets? And if so, whose time are we taking to kind of ask? So a lot of both. I would say a lot of the community collaborators just come from some of my personal relationships as well. So I've done projects where we're including, basically relatives or family members or some of their work that they're doing, trying to figure out how can we take advantage of the already existing community gatherings. One, because I like to be home and be part of them. And then two, how could this maybe spur some of the conversations for research? So I would say a lot of it is just kind of taking work home with me when I'm home, trying to bring them into it as much as I can while I'm here, but then trying to also keep our work moving. I think that's probably the harder balance is how do my grad students not have to wait for something and can continue doing their work, whether or not we're getting the right response, and then how can I manage the response to make sure we're steering in the right direction? So there's a little bit of balance to play there, but it's kind of what makes it fun too. I'll go here. Let's look at this side of the room.
What has been the most surprising or unexpected information?
It's a good question. Actually, one of the ones that surprised me the most was looking through this assessment of the energy, where I was trying to figure out like, why does one scenario tail off for all these other impacts? And it wasn't until I realized like the development of what the high IRA scenario meant compared to the other ones. And so part of it was actually shocking how well it kind of poked a little bit around what's the importance of maybe thinking about how policies might interfere with just market-driven solutions. So that was one that I think surprised me. When we think about kind of all this other data, I think one thing that I was really intrigued around like the dispossession work, right? So trying to connect food systems to our food sovereignty and food impacts onto the dispossession of communities. One thing that didn't really strike me at first that we should include was just layers of temperature and precipitation, which I think were inherently obvious, but at the same time are usually not really included in food productivity data sets and things like that. They might be input parameters, but it's not inherently the product or solution. And the more I was thinking about it was, and the more I was talking to different community members around that project too, they were just like, the theme came back of, well, if we developed all of our traditional knowledge and indigenous knowledge systems within this temperature and precipitation kind of environment, if we go and shift it and move ourselves to a whole new environment, obviously all of the lessons we learned here are not going to be directly applicable. And if you're asking us to change and adapt that learning, then in some ways you're also disconnecting us to our identity. So I think that was something that really wasn't in my mind at first, and then just became glaringly obvious. And so we actually talked, I've written about this before around climate change impacting the identities of people, particularly indigenous peoples, where that traditional practice and wisdom has become their identity, cultural identity. And so I think that's another one that I think was there and obvious, and just maybe a little bit until it kind of like got discussed and pulled out, I think was something that was really strong about that work. Let's keep moving. The two of you, maybe we can just go get both of the questions, and I'll see if I can answer them both back to back. How about that? Try to speed it up.
Yeah, I was wondering about your reductionist approaches.
Sure. Let's hear the second question too.
To start this on this, but there's obviously a lot of potential projects. I'm wondering
Okay, great question. Okay, we'll start with the reduction. The question was around reductionist and holistic approaches. Which ones are we using, and can we point to any of that in the work? Is that correct-ish? Oh, are we using the systems design and thinking approach as one of the holistic approaches? Yeah, so if we think about the systems design, systems thinking and design, a lot of that work, I didn't show a ton of that here because we focused mostly on the community data sets. But for instance, both of these projects are going to be more around integrated systems design. We're looking at how can we use technology to respond to the inputs of nature. So thinking about, for looking at a solar voltaic and atmospheric water harvesting system, right? We're looking at incoming solar radiation. We're looking at the incoming humidity, and like wind is all going to be inputs into the efficiency of that system. From that case, we're integrating it, and the end goal is to put it with a food system. So we have kind of one system design, we have another. So we're in some ways taking ecosystems, trying to put them into our unit operations or processes that we can then include. And so if you're thinking about process systems and design in a more traditional way, one way to think of it is some of these projects we have is trying to take like earth systems and earth functions, putting them into that process systems, and then trying to re-optimize or redesign around a more integrated system. And then the second question was around how do we pick our projects? We kind of introduced a lot of different projects. We work with a lot of communities. How do we pick which ones? It's a great question. I have a really hard time saying no, especially to the community. So in some strategies, what I do a lot as the PI leading the lab is we kind of figure out which ones have really good engineering context. Can we develop a PhD out of that? So a lot of our engineering ones and engineering focused ones, I kind of limit and try to figure out how do we turn that into the development of a graduate student. A lot of these, which are like shifting around data sets and could be really interesting community aspects. A lot of times I will hire undergrads and just kind of say, hey, here's a few opportunities because I don't want to say no to the community. I might not be able to help you a ton, but what do you think you can contribute to this? So I do a lot of work with undergrads to think about shifting different data sets, teaching them kind of the GIS skills, the data analysis, the statistics. Still, we have to say no to a few, or at least sideline them. Sometimes it's just, we don't have time to do that now. If we find the right student, maybe we'll take that on. So I would say the first thing I do is kind of filter them between, can I see like what the engineering aspect is? Is there a design aspect? If it's mostly just analyzing data, then I kind of put it into a different bin that either sits there. If it's something that I just don't think fits our group, then I just say that right away. But if it's something I'm like, yeah, we can definitely do that and we might be the right people for the job, if we don't have the capacity at the time, it sits on in one bin that says, okay, if we have the right student come along, we can bring someone else on to do this. But that's typically the filtering process in my head. I'm gonna move back towards the middle. How about you?
We're talking about balancing demands for transition versus it's that I'm wondering if you expect do you expect a change in work you do or
Well, that's a great question. I would say in general, there's gonna, at this point, it's kind of gonna be hard to imagine people not being impacted by it. But yes, it is definitely impacted. I think part of it is going to be, how do we navigate it in 6 months versus trying to react to it right now? So I've had a lot of people ask me this. My blessing is I'm teaching 2 courses this semester, so my head has just been kind of down and focusing on the students. And by the summer, I'll probably pop my head out and be like, all right, what do I need to know to navigate? What have we learned as kind of a field? It'll be interesting, yeah. In terms of the Paris climate, there are international agreements. We saw this happen in 2016. What ended up happening was US Climate Action Network ended up sending an entire different delegation that was kind of just the worst still in. It was interesting because our federal administration still showed up and was trying to give talks at some of these, even after pulling out of the agreement. It's interesting. I don't know the best way to kind of mention it. It'll be interesting because we're still going to be a major player in the global economy and global trade agreements. So if I had to guess, we're going to continue to send representation to the international climate talks. Will we be constructive and help them move their work along? Probably not. We weren't really at that time. What ended up happening in the last administration was at a certain point, they were just like, well, if you're not in this room, like, why, you just kind of be quiet, because it's just completely counteractive. So we'll see if that happens. We'll see. It's going to be a major player, but in terms of how it impacts all the way down to the work we're doing, in the most case, we'll figure out ways to keep it going. So not really. It'll be disruptive, but nothing in terms of our outcome, just how we get there. Let's move to the left up here. We still have about 11 more minutes for questions, just so you're gauging that with your hands up. So there's still time, is what I'm saying.
how would you encourage like specific classes and departments within Cornell to make sustainability work together and adopt that more holistic approach we talked about?
Yeah, I think that's a great question. I think there's tons of labs doing it from different scales, from different perspectives. I think there could be some interesting like roundtable summits we see this like within systems engineering, did like an on-campus summit around just kind of what is sustainable systems. We might be able to see similar things like that around shared fields. I think what I think could be a really interesting collaboration is trying to help those that really need to do their science in that, in the lab scale. Like if you think about all of the different technologies, a lot of times you just have to be that focused to really get things done. But when you kind of need to put your head up and try to think what's the bigger picture, I think part of the question is, do we have the right network of researchers to kind of help guide that? I think part of it, people are still looking for that. I think some people might be, I think part of it is just making sure you understand that, that your science might be limited. So then you have that perspective and want to go out and bring other people in and get some different feedback. I think part of it is just we've gotten into a routine where we're just doing our research. We've decided that sustainability means reducing carbon. And as long as we can kind of use that as a brand, then we can keep our science going. I think part of it is, how do we actually bring those consequences into a real discussion that we're open to influencing the way we're doing our science, or having some critique? Because I think part of that is one thing I always get is the more that I'm able to do my work, people are more concerned that there's going to look worse when it's not necessarily to look worse. We're just trying to help you find the different opportunities by saying like, here's where this could be a negative impact. But it's not that it means it's not valuable. It's just we need to be more transparent in the research. And so I think that's one that I see a lot of people kind of get uncomfortable around. Will it threaten my science and the value of it? And I hope the answer is no, and we can just figure out how to be more transparent and figure out how to overcome those different obstacles. So I'd say a lot of it is transparency and building that right network. Okay, how about right here in the Cornell shirt?
The effects of wondering how does that compare to other local communities that are not and the second question to that is sort of how does the impact on indigenous population compare to impacts on other ones?
Yeah, that's a great question. So the question is kind of what's the difference between indigenous communities and local communities when we're looking at the impacts? There was another part to that as well. Did I miss it? Okay, and then how do those communities compare? That's a great question. Obviously, I'm driven towards working with the indigenous communities because of my own background. I think what also makes it really interesting is because they have that self-governance, they can make decisions at small scales to move things along. So I actually like it because we are able to kind of put things in and put them to action quicker than if I were to go work with the town of something or the city of something. I think there's a ton of local communities as well. I think part of it is it's really hard to define what makes a local community to make that comparison. There's actually even at the international level, a lot of policy debates around that. How do we differentiate the two? But I think the more we can localize research in general would have a positive benefit for just transparency to help people make decisions. So whether they're an indigenous community that has the self-governance embedded based on their treaty rights or another, a coal mining community in West Virginia that's seeing this huge change, right? I think either way, if we can give them the information and they can make those decisions, they can determine what's going to be most valuable to them, what's going to treat their daily need, what's going to treat their future. And I think to me is if we can help take these like systems-wide perspectives and consequences and then try to help give them enough information at a more detailed level, then we can make, I think, just better informed decisions in general, whether or not they're a local community or indigenous community.
Okay, so I think we should end it there. So let's thank